we have complementars. Even in this intermediate region between 3 and 5, where you have complementars, even though the competitive price will be lower than the price that would emerge with perfect complements. That's all. I hope that I've at least confused you sufficiently to be convinced that this is tricky. Yes? So the point here is that whether we have complements or substitutes is really an equilibrium question. The question is whether in equilibrium we'll get prices that are competitive prices that are above or higher the monopoly level. That's how I define whether you have complements or substitutes, basically. But it's an equilibrium analysis. It really depends on the equilibrium analysis. You cannot just look at the characteristics of price. You really have to look at the demand and what will be the monopoly pricing. And as you see, the comparison is between this essentiality parameter with this monopoly price. The monopoly price depends on the elasticity of the demand. It depends here on the distribution of adoption costs, if you will. So it's really, it relies on a lot of information. So first, I've been careful about using the word I've used is rivalry and complementars, because the question that is relevant for my policy problem is whether the cooperation would lead to higher prices or lower prices. We want to encourage cooperation when it aims at avoiding double margination and royalty stacking, patent thicket, and the like, and result in lower prices. Instead, we want to prevent collusion, cartelization that aims at raising prices. And that's exactly how I'm defining the relevant regimes. Yes, we have complements when the monopoly price is below the competitive price. Rivalry. But if you were to look at, of course here you would have a bit of difficulties using a partial derivative because you have the demand that is lumpy. But if you want to look at the equivalent, the point is that you cannot have an unambiguous answer. Depending on the price levels, the sign may be positive or negative, which is the whole point of the analysis. The asymmetry here is so it does not really matter here because the total price is uniquely defined. So the competitive price for the bundle is uniquely defined, and that's what matters for that definition. So here's the more general framework I'm going to use, which basically follows the same steps. So you have, for the moment being, two symmetric firms. We do extend in the paper to more than two and to asymmetric firms. The technology brings some value, capital V, if you buy both products, both patents, if you wish. V minus E only if you buy only one patent. You have a general distribution over the adoption cost. So you can play with the demand elasticity the way you want in this. So the relevant range for the adoption cost is anywhere between 0 and capital V. Of course, if it is higher than capital V, the technology will not be adopted if it is it cannot be negative. So that's the relevant range. What is nice, at the same time it's a limitation, but what is nice in this framework is that conditional on adopting the technologies, all the users have the same preferences over the baskets. So they will all choose the same basket. So it means that there is no scope for price discrimination here. There is no scope for mixed bundling. We were discussing mixed bundling before. Here we have a setup that evacuates any need for mixed bundling. So without loss of generality, I can restrict attention to two prices, one price for each product. That's it. All the consumers agree that the value of the technology is capital V if they buy both patents. All consumers agree that the value is V minus E if they buy one patent, either one. So we assume symmetry in that sense, but what is important here is that all consumers agree on what is the value of you are buying this patent only, or what is the value of buying that patent only. So that simplifies a lot. It's also a restriction, obviously, but that allows us to really focus on price levels rather than price discrimination or allocation. It also means that having a joint marketing alliance does not improve the scope for discrimination. So it's pretty clean in that sense. We're only concerned with the impact of a marketing alliance on the price levels as well. So the distribution for the bundle, if the bundle of the two patents is proposed as a total price of capital P, then the demand comes from all those consumers who have a cost which is smaller than the net value of V minus P. It costs C to adopt the technology. If your cost is below V minus P, it's worth adopting it. If your cost is above, it's not worth. So the demand is the number of users that have a cost that is lower than V minus capital P. That's the demand for the bundle. F is, yes, I'm sorry, is the CDF for on the cost. If the users buy only the incomplete version of the technology with only one patent, then the demand is, the value of the incomplete technology is only V minus E. So you have to pay small p for that product. So if your adoption cost is lower than this, you are willing to buy it. If your adoption cost is above this, you are not willing to buy it. So and you can see by analogy that this is the demand that corresponds to a total price, a total effective price, if you wish, of P plus E. So the demand for a product, if the cheapest of the two products is proposed at the price of small p, then the demand for that product will be D of P plus E. So you can think of P plus E as being the effective price, total price for it's a quality adjusted price, if you wish, for the incomplete technology. So the price of small p plus E is the same thing as the total price of capital P of P equal to P plus E for the complete technology. Make some regulatory assumption on the demand that ensures that all the profit functions are concave and well-behaved and so forth. With the IP interpretation in mind, we normalize to zero the cost of actually producing the goods. You can think of a patent, and issuing a license does not involve any cost. So the profit per license, if both licenses or both products are offered at the price of a small p, then the profit per product is P times the demand for a total price of 2P. If instead only one product is sold at a price of small p, then the profit for that product generated by the product is P times this demand based on an adjusted price of P plus E. And you can denote by PM and pi m and p theta m and pi theta m the corresponding monopoly levels for the prices and profits.
So you assume that the cost of adoption is the same for either technology. Does it make any difference?
Yes, there is only one technology, and you can go for the full version or the small version. So you have to decide whether to adopt. No, you have to decide whether you are going to invest in a 3G technology, and then you can go for the gold-plated version or the limited version of it. But yes, the adoption cost is the same. Yeah.
Doesn't make any difference?
Well, what matters is that all consumers agree, conditional on adopting the technology, all consumers agree on the value of the full version or the small version. That's really what matters. Now, here you have 3 products, 1, 2, and 1 plus 2. So you could have a characteristic, a utility for product 1, a utility for product 2, a utility for product 1 plus 2. for the bundle. We assume symmetry, so we are down to 2 dimensions. And then we have added one restriction, which is that conditional adopting, everyone agrees. So that's really that is the restriction we are making. This is the assumption we are making. The static equilibrium is, it's the same as before. There are 2 types of candidate Nash equilibrium. One is where, given the Nash equilibrium, if I was to raise my price, starting from the Nash equilibrium, if I was to raise my price, then my product will be evicted from the basket. And in that case, the Nash equilibrium is such that both firms charge a price equal to this essentiality parameter, E. So if I was to raise my price, then users would buy the incomplete version of the technology without my product. The other possibility is that if I raise my price, then the users that are buying the technology will keep buying both products, but there will be fewer of them because the total price for the technology is bigger. And that will be this is, in that case, if I depart from the candidate equilibrium, then I will get a profit of P times D. The other one is offering its own piece at